Hello, and welcome to Statistics. Today, we're going to talk about Chapter 1, an introduction to statistics. And so the fundamental question is really, what is statistics? Statistics is nothing more than the study of probability, which is measuring chance. And when we talk about statistics moving forward, there are really two categories of statistics that we're going to delve into in this class: descriptive statistics and inferential statistics. Descriptive statistics is all about summarizing data that we already have, right? Summarizing existing data. We've collected a data set and we want to know what's the standard deviation of the data set, what's the mean of the data set, what's the probability that another data value is gonna be a certain value given the data set we already have. Inferential statistics is making predictions about a data set before we've collected it. That would be like, what do we think the mean of an incoming data set is? Or how likely is it that the proportion that a certain data set has a characteristic before we collect it is within a certain confidence interval? Inferential statistics is what we will study more towards the later half of this course. So where do we get these data sets? Well, there are two main ways we can get the data sets. A population is really going to be all possible values from the group. That is going to be every possible data value we could get. Anytime you run any sort of experiment, we will get a sample, which is some sort of sub-collection from our data population. So if we move into section 1.1, statistics and critical thinking, we can define really the fundamental object of what statistics measures, right? Algebra has functions, calculus has change, arithmetic has real numbers. Well, the fundamental object of probability and statistics is what we call a variable. And a variable is just a characteristic that's going to change over time for various conditions. So an example would be like hair color. As we look at different people, their hair color might be different. That's a variable. White blood cell count in a human being. As we check from patient to patient in the hospital, their white blood cell count might be different. Or time for failure of a new phone battery, right? From device manufacturer to device manufacturer, those time to failures, whether it be 1,000 charges, 2,000 charges, there's going to be a time to failure that's going to be different. Right? And we may be able to measure more than one thing at a time. And the way we talk about this is the type of data we have. And we can have what we call bivariate or univariate data. And we look at kind of the prefixes of those two words. So univariate data is going to be one variable is measured. That's what we're going to do for really the majority of this course, is looking at univariate data. Bivariate data is really going to be having two variables that we're going to measure at the same time. That is really when we start talking about linear relationship, like barometric pressure and temperature. We might look at a day and measure those two things. That is bivariate data, where we kind of have two measurements, two separate things, two variables we're going to measure at a time. So let's really just kind of talk about the different types of data we might have. Data can really be broken down in kind of this chart. We can talk about qualitative categorical data, or quantitative or discrete and continuous data. So qualitative and categorical are like the quality of our data, right? They're going to talk about really the quality or characteristic of the data that we have. That is where like hair color, gender, or jersey number might be. Right? Even though a jersey number is a number, right? Qualitative data doesn't mean it can't be numeric. It can't be a number. But for the most part, the jersey number of an athlete has nothing to do with their skill, right? Someone in basketball that wears 6 or wears 10 doesn't mean one is necessarily better than the other, right? That's just the quality of something about them. Quantitative data, on the other hand, really measures kind of a numeric quantity. There are different levels of quantitative data, like interval or ratio, We're really not going to get into that. But what we want to take away from quantitative data is that there are really two different types of numbers. We can have what we call discrete data or continuous data, right? Discrete data is when there's only a finite or countable number of values, right? We have a finite or countable number of values. That's gonna take up the majority of what we're gonna talk about in this class. That all discrete data is really gonna come up all the way up to chapter 5. Continuous data is when we can assume infinitely many values, and not just infinitely many values, but the key is those values have to correspond to a line interval. And that's really going to come up when we talk about decimals, right? So an example, the number of cars involved in an accident, right? This would be discrete data because there is a finite number of cars involved in an accident, or I can at least count the number of cars involved in an accident. Time, on the other hand, is what we consider continuous data, because when we measure time, we typically are going to measure that on a time interval, because there's way too many outcomes. And sometimes that idea of having like way too many outcomes can really push us into dealing with continuous data. All right. Hopefully this was helpful. That is really the end of chapter 1. It's just really just a brief overview. We'll come back a little bit more in chapter 2 when we talk about how we can take this data and start to visualize it and put it in a more pleasing aesthetic. If you have any questions, feel free to reach out to me. And if not, I'll see you all next time.